Hello everyone, welcome back to Math with Amala. Here we start a new chapter of grade 10, chapter number 2, Polynomials. And here we deals the all concepts of this chapter. What do you mean by the polynomial? Before that, what do you mean by algebraic expression and algebraic equation? We know that if we consider some algebraic expression of the form 5x square plus 3x plus 2, then this is an expression. If we have an equal to sign, you can call it like an equation, and the degree of this polynomial is the highest power of x in p of x. Here p of x is the polynomial 5x square plus 3x plus 2, then degree is called the highest power of x. Here it is 2. If it is 1, the degree is 1, it is called a linear polynomial. If the degree is 2, it is called a quadratic polynomial. If the degree is 3, it is called a cubic polynomial. So here we have quadratic polynomial, and if we consider only the 3x plus 2, it is of degree 1. It is a linear polynomial. Now we can take the example for cubic polynomial as 3x cube plus 5x square plus 3x plus 2. Here we have four terms, and the degree of the polynomial is 3, and it is a cubic polynomial, and you can consider it as p of x. Okay, now we have to replace the x in all this p of x with k. K is any real number, then you will get the value of p of x at x equal to k. You are getting the value of p of x at x equal to k. So you have to note that here by substituting k in this p of x, you are getting value. But when we move to the next portion, you are having a 0 of the polynomial. What do you mean by the 0 of a polynomial? Let us take a k. It can be any real number, and k is a 0 of p of x if p of k is equal to 0. That means if we take that expression into an equation, then you will get that p of k is equal to 0. At that point, you can take that k as the 0 of the polynomial. So that equal to 0 and ze0 0 are different from each other. And in general, for 0 of linear polynomial ax plus b, we can take the 0 as minus b by a. If we have 3x plus 2, then the 0 of that expression or polynomial is minus 2 by 3. Here minus b means b is the constant term and a is the coefficient of x. Now the geometrical meaning of the zeros of a polynomial. Let us first discuss the linear polynomial. Linear polynomial means it is in the form ax plus b, where a not equal to 0. The graph of y equal to ax plus b is straight line. You can plot it in a xy axis or xy coordinate. You can see that it is a straight line which intersects x-axis at exactly one point, namely minus b by a comma 0. So this is the solution or the 0 of the polynomial y equal to ax plus b. Here we are transforming this expression or polynomial into an equation which includes both x and y variables in order to plot in the xy coordinate. Now ax plus b has exactly one 0. Only one 0 is there, that is minus b by a comma 0. That means the coordinate of the solution or the 0. X coordinate of point where graph y equal to x plus b intersects the x-axis. So that 0 is found on the x coordinate or the x-axis, and that is the x coordinate of point where graph y equal to ax plus b intersects. Here in this graph you can see that this is the center or the origin is the solution of the equation. Okay, so you can just think about what kind of polynomial it will be. Here x-axis and y-axis are having the same coordinate 0, 0. So what will be that? Y is 0 and also ax plus b is 0. That means you can have it is just a single 0 as the 0 is the our polynomial. Okay, 0 is the polynomial. Next, let's move to the quadratic polynomial. Here ax square plus bx plus c is the quadratic polynomial with a not equal to 0, and you can give it like an equation with y is equal to ax square plus bx plus c in order to have both the axes has two shapes according to a greater than 0 or a less than 0. A is not equal to 0 means a can be positive or negative. If a is greater than 0, you can see that it is a parabola with upward open. Then when it is less than 0 or any negative number, you can see that it is a parabola with the inward opening. These kind of figures are called parabolas. Here you can see that if we take x square means you are having two values. Let us take x square is equal to 4. Then x is having two values. X square equal to 4 means x is root of plus or minus root of 4, that is plus 2 or minus 2. Hence it have two values. That's why it is the geometrical representation is coming with a parabola. Therefore, the zeros of a quadratic polynomial x square plus bx plus c, where a not equal to 0, are precisely the coordinates, the x coordinates of the points where the parabola representing y equal to ax square plus bx plus c intersects x-axis. So there are three chances for this intersection with the x-axis. As we discussed before, we can see that when we have an intersection with the x-axis, you will get that point as the zero of the polynomial. Here we have three cases. The two zeros, you can look at the graph also. The first case says about the two zeros. Second case, 1 0, only 1 0. And the last case, there are no zeros. Okay. So here two zeros means you will have the parabola like this, like the first one. Here you can have a and a dash as 2 points of the first parabola, b and b dash as the 2 points or the two zeros of the second parabola. Here you will have two zeros. Then the parabola can, it is possible to come like the second one also. Here you will have a as the upward parabola, a as 0 and b as 0 for the inward parabola. And there are no zeros for the last case, which means it is not intersecting with the x-axis. Polynomials of degree 2 has at most two zeros. It is a common general case. Polynomials of degree 2 has at most two zeros. You can have no zeros, 1 0 and at most two zeros. Now let us discuss the case of cubic polynomial. Ax cube plus bx square plus cx plus d is the cubic polynomial. Here also you can have by graphical representation also you can see that there are 3 points where the graph meets the x-axis. So you can see any polynomial of degree 3 can have at most 3 zeros. We have already seen that any polynomial of degree 2 can have at most 2 zeros. So in general, given a polynomial of degree n, the graph of y equal to p of x intersects the x-axis at most n points. Therefore, a polynomial p of x of degree n has at most n zeros. Thank you all for watching the video. Please stay tuned for the exercise part of the same chapter.